In this video, I will show you how to calculate the midpoint, the length, and the slope of a segment given its endpoints. And ultimately, I will also show you how to find the equation of the line that goes through those 2 points. Okay, so first of all, the midpoint. Well, we have a midpoint formula which goes like this. The midpoint formula says x plus x divided by 2. In other words, the average of the x's. And then y plus y divided by 2. All right, that's the average of the y's. So that's all there is really to it. So we're going to do negative 8 plus 2 divided by 2. And then we're going to do negative 20 plus negative 5 divided by 2. All right, so that's going to give us negative 6 divided by 2 and negative 25 divided by 2. And so the bottom line is we will have negative 3 and negative 12.5. All right, so that is the midpoint of this segment. Now, how do I find the length? Well, we have something called the distance formula, which is actually given to us on this paper. So here's the distance formula right here. All right, is the square root of x minus x squared plus y minus y squared. So this is what I'm about to use. All right, if I could just scroll back down to it real quick. So that was the square root of x minus x squared. All right, so that's going to be 2 minus negative 8, or in other words, 2 plus 8 squared, because when you subtract a negative number, you add. And then now we're going to do y minus y. So again, that's going to be negative 5, but then I'm going to do plus 20 because minus and negative is a positive. So I could break this down step by step, but I could also type this whole thing into my calculator. So I think first I'm just going to show you that you can type the whole thing in your calculator. So we have 2 plus 8 squared, so you could literally do 2 plus 8 squared. And then we have negative 5 plus 20, negative 5 plus 20. And we could square that. Okay, so that's going to give us 5 radical 13, but I think they want a decimal. So that's going to be 18 point, how many decimals? 1 decimal place, so 18.0 actually. So the answer is going to be 18.0. So that's what happens if you just type the whole thing in your calculator. Here's what it looks like if you break it down a little bit further. So obviously 2 plus 8 is 10, so I'm going to have 10 squared. Negative 5 plus 25 is 15. So I'm going to have 15 squared. So maybe you would show that work. And then 10 squared is 100. 15 squared is 225. So together that makes 325. So maybe you would have done all that work by hand. And then you would have done the square root of 325. But that'll give you the same answer, of course. So that's how you find the length of a segment. Now, let's find the slope. We know that slope is rise over run. Maybe I'll write that down. Slope is rise over run. But as a formula, the rise is always going to be the y value minus the y value. and the run will be the x minus the x. So that's what we're going to do. Okay, so the y minus the y is really what we had put right here. It's going to be the negative 5 plus 20, right? Negative 5 plus 20. And the x minus x is what we had right here. It's going to wind up being 2 plus 8. Because 2 minus negative 8 is the same as 2 plus 8. And so the rise is going to turn out to be the number that we got right here, which is 15, and the run is the 10. But we are supposed to have a reduced fraction. So let's go ahead and reduce this down. And so both of these are divisible by 5. So if we divide both of these by 5, we're going to get 3 over 2. So that is the slope. Okay, now find the equation of the line GH. I mean, it says segment GH, but I really think they mean line GH. Okay, so the equation, we're going to use slope-intercept form. So we know that y is equal to mx plus b. So all we need is the m and the b. We already have the slope, so we can just write that down. Okay, so the slope is 3 over 2. All right, so all we need is the y-intercept now. Okay, so this is going to be, so just pick one of these points to use. Doesn't matter which one. I think I'm going to pick this one. So we've got the x and we've got the y. All right, so x is 2 and y is negative 5. In fact, let me just rewrite that. So 2 comma negative 5. This is what we're using. So y equals mx plus b becomes negative 5 is equal to 3 over 2 times 2 plus b. So I know these 2's are just going to cancel each other out, and I'm going to end up with negative 5 is equal to 3 plus b. Right? The 2's cancel out. But maybe you wouldn't have noticed that, and maybe you're more of a calculator person. So you could just type this in, 3 over 2 times 2. It's silly because the 2's just cancel out, but hey, some kids just never get the hang of that. Oh, look, it's 3 because the 2's cancel out. All right, get on my level, people. Try hard. So subtracting these, I'm going to get negative 8. So b is negative 8. And now that will give me the equation. So now I can write y is equal to 3 over 2x minus 8. Okay, what is going on here? If a, b, and c, d are congruent, and a, b, and c, d bisect each other, then a, b, and c, d must have the same blank. Circle all that apply. Well, congruent means same length. Okay, so because they are congruent, they will have the same length. If they bisect each other, that means they have the same midpoint. So there you go. Which of these quadrilaterals always have only one pair of parallel sides? Well, that's the definition of trapezoid. Yeah, so that's it. Which of these quadrilaterals always have diagonals that bisect each other? Okay, well, we memorized that that's one of the special properties of a parallelogram. But that automatically means that we're going to also circle rhombus and square, because rhombus, square, and rectangle, those are all parallelograms. So we have to, anything that applies to a parallelogram automatically applies to those as well. But this property is a property of a parallelogram, but that's why we circle parallelogram and then we circle the other two. If rectangle had been here, we would have circled that too. All right, in the next video, we're going to go a step further and I will show you how to prove different properties of special quadrilaterals.